right, so let's think back and review kind of our concepts of functions. So what is a function? A function is a rule that has a unique output for each input. That means there is only y for each value of x. So if you remember, our x's could not repeat, whether that was in a table or in a set of coordinates. The x values could not repeat. What are domain and range? Domain are the x coordinates and range are the y coordinates. All right, so this we're going to kind of ignore. All right, a graph of a linear equation is a line. I'm pretty sure we all remember that part. A linear equation represents a situation relationship. So that's why when we take the slope, no matter what points we take the slope from in a line, you're always going to get the same slope because it is proportionately from your x's and your y's is proportional. It's a straight line and there are no curves. To graph linear equations, we can create a table. So a lot of times we were taking and starting with our b, which was our y-intercept, and moving our slope. You can also create a table. We can plot the points and then connect them to form a linear function. And this is sort of just the revisiting of information. Now we're going to go see what we can do with this. So function rules. Function rules is basically just an equation. A rule will often fit a certain situation, which is why we call it a rule. So here we've been given a function, and it's y equals x minus 3. Now, function usually implies that we're going to have an f of x equals x. This is more of an equation notation. That's more of a function notation, but it's the same exact thing. Same exact thing. F of x is the same as y. So then I've set up our table, and we're going to have our inputs of x and our outputs of y. So in here, I'm going to put our function rule. Our function rule is y is equal to x minus 3. So I'm going to kind of touch on something that we kind of skipped over because of the virtual aspect of this. But when you do it as a function, we use this notation. And what I'm going to do is I'm going to pick points just like you've done a ton of times. We're going to create a table. If you're using function notation, we would say, well, what is f? So we're taking -2 and we're plugging it in for x. So over here where I have my x, I'm going to do -2. And then I evaluate the right-hand side. -2 minus 3 is -5. So f of -2 is -5. And I'm going to show you another one, f of -1. So what is the value of the function evaluated at -1? So we're going to take -1 and plug it in for x. So -1 minus 3, we get -4. So -1 minus 3, -4. F of 0, we get 0. 3. F of 1, 1 minus 3 is -2. F of 2, 2 minus 3 is -1. And now we've created a table, and I'll just show you. This is the input and output. This is our x coordinate and our y coordinate for this equation or the function. And then we're going to plot our points. So -2, -5, -1, -4, 0, -3, 1, -2, and 2, -1. And there we get our line. One thing I want is I specified my start point and my stop point to create this graph. The reality is we could put any value of x in and we would get continued proportionally related values of y to come out. But one thing I wanted to kind of practice is our domain and range. So we're going to take the we've graphed. So looking from left to right, what is our leftmost x value? That's this point right here. That's the x value of -2. We are including that point. That is part of our coordinates. So I'm going to do a bracket, -2. And then our rightmost point is the x value of 2. And again, in this graph, this is a solid. So again, we have a bracket. Range, our lowest point on our y-axis is -5. And our upper y point is -1. Again, brackets, because on this graph right here, our endpoints are included. All right, so y equals -3x. So again, we could look at this as a function. F of x equals -3x. And then we could evaluate our function at various x values. But I'm just going to kind of do it on this graph for now. So I picked -1, 0, 1, 2, and 3. And 1 is +3. -3 times 0 is 0. -3 times 1 is -3. -3 times 2 is -6. And -3 times 3 is -9. All right, and I'm not going to rewrite them, but I'm going to plot these points as my xy coordinates. -1, +3. 1, -3. 2, -6. And 3, -9. And then we can connect our points. And again, just like on the front, we could have other lower x inputs and higher. Given the function would go on and on forever. But I wanted to, again, practice domain and range of just this graph, not of the function. So our leftmost x value is -1. We are including that on this given graph. Our rightmost x value is 3. Our bottommost 9. And our uppermost y value is at 3. All right. Function rule. F of x equals -3x plus 2. So this time I'm going to go -3, -2, -1, 0, and 1. Or our function rule. And we're going to evaluate our function at each of these given x values. So -3 times -3 plus 2 gives us 11. -3 times -2 plus 2 gives us 8. Plus 2 is giving us 5. -3 times 0 plus 2 gives us 2. -3 times 1 plus 2, -1. So now we're going to plot our points. -3, +11, look at that, actually off the graph. -2, 8. 8. -1, 0. And 0, hold on, oh, -1, 5, 0, 2, so that point there is wrong, and then 1, -1. There we go. And again, could go on and on forever. The domain and range of just this graph. Our leftmost point is at x is -3. Our rightmost x point is at 1. Our range, so our y values, our lowest y value is at -1. And our highest y value went off the chart, that was at 11. All right, and find 4 solutions to each equation and write the solutions as an ordered pair. I don't know if I'm going to do 4. So you could solve for y here, or you could plug in and then solve for y. I left it the way it is, so I guess I'll go ahead and do that. But I'm not going to do all 4 points. So 0 is always a good one because it usually makes solving pretty easy. And then I'm going to do 1. So then we're going to just take our 0 and our 1 and each plug it in for our x. So 0 minus y equals 3. If we solve for y, -1, we get -3. And then 1 minus y equals 3. Subtract the 1, so you get -y equals 2. Divide y is equal to -2. So 2 ordered pairs for this equation are 0, -3, and 1, -2. I'm going to set up my table. Didn't leave a lot of room there. All right, I'm going to go 0 and 1 again. So 5 times 0 is, or sorry, minus 6 gives us -6. 5 times 1 minus 6 gives us -1. So 2 coordinate pairs from that would be 0, -6. And again, you can put in any values that you want. All right, so here I'm just going to take advantage of the fact that I want to pick numbers that will easily divide by 2 for my x's. So I'm going to go ahead and do 2. I'll do 3 this time. 2, 4, and 6. So this, which is 1. 4 divided by 2, which is 2. And then 6 divided by 2, which is 3. So we could look at this as 2, 1, 4, 2, and 6, 3. But again, any inputs, any outputs, you might get decimals. That's okay because it is a continuous function. It is still a valid answer.